So I'm going to talk about Transit on the Go. This talk is about an app that I've developed for my smartwatch to help me catch a subway. And this is not related to my work, it's just a personal project that I've been working on. I work at Bloomberg, so clearly you will realize it's not at all related to what I do at work. It's very tangential, and to give you a little bit of motivation as to why I actually ended up doing this, I'll give you a little bit of feedback, a little bit of insight into my daily routine. So I live in New Jersey, and well, not way inside New Jersey, so I'm not like a lost cause, but still very close to New York, but still it's New Jersey. So I have to take a bus, and then I get into New York at Port Authority, I take a subway, get to my office at Midtown. So that's kind of my daily routine. And so you can imagine I probably wake up, get ready by around 9, that's being very charitable, probably get there a little late, but let's say I get ready by 9 and I'm on the way to my bus stop. So as usual, I'm late again, and this is a very common routine for me, so I end up having to run to make sure that I don't miss the bus. So let's see, do I actually make it? So there's the bus, it's getting away, can I make it? I'm not so sure. Oh, okay, that's it. I've given up, so yeah, I don't make it. I'm pretty sad, yeah. I mean, this is a little bit of an exaggeration. I don't run on the street, well, not always. And I certainly don't try to chase a bus that is clearly getting away from me, but it's not too far from the truth. Like, I do end up getting to this bus stop a little late, like miss it by a few seconds, and then I end up getting frustrated and have to wait for like 5 minutes for the next bus. But anyway, I do catch the next bus, hopefully, unless it's full, and then I catch the next bus. And eventually, many moments later, it's 9:30. Again, it's not an unusual occurrence, I'm late. So I want to make sure that I don't get too late to the office. So yet again, I start running. Alright, so Times Square, that's where I get the train. Do you think I can make it? Oh, nope, not happening. So as you can see, I wasn't careful. I didn't take a look at the service notification. It says that there's no weekend service, and bam, there's no weekday service either. Yeah, so I'm screwed. Okay, fair point, MTA is not that hopeless, but it did happen a few times. Like I ended up I take the NRW, I ended up going to the platform only to realize that there's no trains. I go to a different platform, take this shuttle to Grand Central, etc., or it will be as simple as I'll be late by a few minutes, and then it's a frustrating experience of waiting for 5-10 minutes. So this whole situation makes me really sad and upset and confused, but then I get an idea and a bulb glows on top of my head. So I have a watch, and clearly it can talk back, so it must be smart. So it's a smartwatch, and it's not that smart. So anyway, I broke its heart. Well, the watch I'm talking about is a Garmin Vivak 2-3. It's essentially a fitness tracker. It's not really a smartwatch like an Apple Watch. It's a very bare bones, low power fitness tracker which can also do some smart stuff. So you can see there are a couple of apps I have up there like NJ Transit and MTA, which is what I built. If you notice, there's also run. It's not telling me to run to the bus stop or just run to work. It's a fitness activity. It runs Garmin Connect IQ platform. So these apps run on this platform. You can build them, and they use something called Monkey See. So I'm going to talk about just the MTA app for now. And this app, like any other Connect IQ app, is written in Monkey See, and you didn't mishear me. It is indeed called Monkey See. And it's a bespoke object-oriented language developed for Garmin. It runs on Monkey Brains VM on the Garmin's real-time operating system. So, short note, like it's called Monkey See and Monkey Brains because the guy who made it works for Garmin and he likes monkeys. He just didn't realize that marketing will just run with it. So they stuck with me. Okay. Coming back to my app, it uses a little bit of backend service that I've written on a server sitting in the cloud, and that's actually the brains of the app. So the app on the client side is just simply a client. It sends us request and it gets the data, but the main brains is on the backend. So it gets the MTA data. It uses GTFS real time, and I've written a GTFS real time parser in all languages. Well, I chose the best one I could think of, PHP. Well, side note on that was when I first did this, I just have a personal hosting website to use host WordPress. Turns out I could only run PHP stuff. Now they actually let me do more useful things like Node.js and Python. But when I first did this, PHP was the only option. So Yeah. Anyway, so I'm going to focus on the server. That's the main brains of this app. So I'm just going to focus on that. So let's zoom in and let's see what I did there. So before I talk about what I did there, I'm going to give you a brief, very brief rundown of GTFS real time. Like I'm sure a lot of people over here know what it is, but this was actually the thing that kind of stopped me in my track before I could get further along in this app development. I'm obviously not from a transit background, so I was really a little nervous with GTFS real time. But if anybody over here is interested in developing an app like this, I'm here to tell it's not that complicated. So anyway, with that said, well, GTFS real time, as you might already know, is like de facto standard for what you call the transit data that you can deal with. So it's a binary file, and its format is defined by something called the protocol buffer. It's you can think of it as a schema, and it's language extensible. It's extensible and it's language neutral, and so and the schema kind of defines how the structure of the binary file is. And this binary file contains all the data that you can think of corresponding to a particular transit system. It's very compact, so a lot of hard work will be done on your app side. So let's see what the standard protocol buffer definition looks like. That's a GTFS real time. That's part of the standard. So it has something called a feed message object, which itself contains something called a feed header object. It also contains something called feed entity. It's an array. It's a list of items. The feed header is not something I'm very interested in. It has like things like version, timestamp, etc. The feed entity contains some useful stuff like vehicle position, alerts, ID. Alerts might be useful for an app that tries to figure out if there's a service alert. Maybe some train is not running. But for the sake of my app, I was more focused on the trip update. That in turn contains like something called descriptor. This descriptor contains an ID. Now MTA defines this ID like so. Like this is an example. So the first part of the ID is the origin time starting from midnight in hundredths of a minute, and the second part is the train ID, like 2 for the 2 train and W, etc. The first letter there, direction, is the direction, north for uptown and south for downtown, and so N and S. And then there's also something called stop time updates, which is like the most useful thing for me for my app. It contains it contains one entry for each stop you can think of. So in each stop has an ID, and it says an arrival and departure times for that. So that's kind of on the whole the design of this protocol buffer. And this is an example of what the stop IDs look like. So these all three actually correspond to Times Square. In fact, there are more IDs for Times Square, even more. The reason is like each line has its own unique stop ID, and in fact each direction, uptown and downtown, has its unique ID. So the N at the end is like again northbound, that is uptown, and S is southbound, downtown. So anyway, so that's kind of a complicated mess. It's actually pretty, it's complicated for me when I first started working on it, but it's actually very elegant. Like once I figured out what's the madness behind this whole thing. So this was the main thing that I need to understand to get to building the app. Once I figured this out, it was actually very straightforward. So once I had this picture in mind, and beside, by the way, there's a little bit more. So these 3 items which I've just highlighted, it's something you can that the MTA decided to extend. And so when I say extend, they actually just added extra information on top of it. And the cool thing about how this standard is defined is if you're not interested in the extensions, you can treat the data that is generated by the extended protocol buffer as if it was just generated by the simple one. And whatever code you have written that handles the files generated by the simple version, you can still use the same code. It's just that you won't be able to access whatever extra information you want, which is fine for me. I don't really need the extensions. Anyway, so with this picture in mind, let's go back to PHP, our favorite language. So it's actually very straightforward. Google actually has a bunch of libraries, essentially, bindings for GTFS real time. So if you are using PHP, for example, you can use Composer with your project to include the dependency. And then the next bit is very straightforward. You just include that dependency into your code, include that using that requirement statement, then just get the data using the URL that MTA gives you. You have your unique developer key, the feed ID. So feed ID 16 over here in this example is for NRWQ. And then you just create this feed message object. If you remember from the previous slide, feed message is the main, information in the binary file, and then it contains an entity list. So you get the entity list, and then for each entity within that list, blah blah blah. You just kind of go through the whole data the way you want to, and do whatever you need to do for your app. So, and then you do the same thing for Node.js. A little bit neater, so you can use npm to install the dependency, use it in the code, create this request object, create the request, send the request, and then use the feed entities, feed messages decode method to decode the data, and then again go through the same thing. And then I guess Python is the easiest if you think about it. It looks nice, it looks neat, and it's actually the easiest to understand. You don't have to break your head to see what's going on. So again, install the dependency using pip, create the request, use the parse from string method to decode the data, and then again go through the same thing. Multiple for loops to just get the data. So that's the very high level idea of how to deal with the data. And then now that I had that in mind, and all these examples, by the way, are like the standard examples that you see on the GTFS real-time website that Google hosts. So these are you can go there and get a better sense of it if you want to. And then as far as for my app, I had to create a REST API. So obviously it's not just enough to do that. I have to be able to send some data. So the client on my wrist that I have over here will send some data like this. So it's basically JSON formatted. And it's, say for example, I'm interested in NRE4. These are the trains I'm interested in. Those are the stop IDs for each of the train I'm interested in, say. And then all I do is then on the back end, now for each of these trains, just go through them, now figure out which file I need to download, because some of these trains come from different feeds. So figure that out, download the appropriate files, the binary files, parse it, and then just go through it. It's like multiple for loops, nothing high fancy stuff over here, just for loops, and figure out the data for n, find the information for the n train, for particular stops, get the arrival times and so on and so forth. And eventually it spits out this kind of format. So this is just something I've decided upon for my application. So of course, if you want to do it, you might end up choosing a different format in which you need to give the data back. But this is what I did. And yeah, so that's the presentation bit. Let's show them. Interesting. Okay. So this is the app that is actually showing you more than I wanted to show you. So this is the app when you first launch it. So it shows a list of stops you're interested in. So I just have it configured to show things like Times Square, 42nd Street, Lex 59, which is the one near my office, Lex 63, 53, blah blah blah, and so on. And then say if I'm interested in Times Square, I click on that, and I'm interested in basically the NRWQ northbound trains, uptown trains. So that's the N train, uptown is actually live. So right now it's 7:19, and the next train is in about 2 minutes, more or less. And then the list over there below is just the next 5 trains basically. And then I can go through the other trains, the WQ, blah blah blah, and then kind of scroll up and scroll down to go and check different stops. I mean, this is just to give you a sense of the final picture. That's obviously beyond the scope of this talk, but this is how I ended up using the data that I get for creating the app. That's about it.
We can do questions. 2 questions. Anybody?
Yeah. So, connectivity has gotten better in the subway system, but there's still definitely places where signal will come in and out. So what's the actual connection protocol between the smartwatch and your API?
So the way this works is the smartwatch simply sends requests via Bluetooth to the phone. The phone in turn just then tries to connect to the internet and get the data back, and then sends it back via Bluetooth. So it's usually that way. I mean, obviously different smartwatches work differently, but this is kind of how Garmin does it. And yeah, it's going to be problematic when you don't have internet, or if you have kind of spotty connections. It just depends upon what your phone can do. Yeah.
Cool. We have time for one more question for Abhijit. Anybody has curiosity? Yeah.
Can you
crew, no upcoming schedule. That doesn't sound good. So, can you repeat that? What did you say?
Just on a previous slide,
Mm-hmm.
just walk through when it's actually displaying.
On the right side?
No, sorry, the image itself.
Oh.
Watch.
Oh, yeah, okay, sure.
Yeah, the elements of the interface.
Yeah, sure. So you can see that the top is the Q. Now I've used the V or the down arrow to denote like downtown, and in another case for uptown I'm using this kind of a upward arrow. So that's just my kind of a little hacky way to do this, because the character said that this support is kind of limited. I mean, I could have used pictures to do that, but I just decided to do it in this kind of low-key fashion. And then the second one, the green text, that's just the current time. The time below that is the time of the next arrival, and then 0 minutes just says, okay, it's within less than a minute. And then the 5 numbers you see below that is the list of 5 next arrival times. So 0 being the earliest, and then 6, 19, 35, and so on. And then the next is just a bunch of dots to kind of like let you know that there are more trains that I've shown over here. So like 4 different trains. Yeah.
Cool. Well, thank you, Abhijit.